Hello, and thank you all for joining us today. Obviously, we are Columbus Cali and Larry Rambo, both of us Purkeys account managers. Been with the company several years each, but we wanted to kind of do something a little bit different today, and we're going to talk about wire repairs. This could be a 10-hour long webinar, so we tried to cut down to some of the basic things. But one of the things is we do also want to stress on this is, we're trying to go over things, the proper repairs. There's times you got to do, a roadside repair, or whatever, and some of the best practices may go out the window just because of safety, things like that. But one of the things we do want to stress is to do these wire repairs, not just to fix it, but to be a long-term fix. I talk to fleets all the time that have repeat failures, and you go out and look, and it's because it's poor repairs. That corrosion gets in there, or this mechanically they fail. And if you look at how long we hold on to equipment, especially trailers, we do have to take the time to do these repairs right. We always say we don't have time to do it right. Yeah, but we have time to do it 5 times. So again, just to go into a little bit more on proper ways to do some of these repairs. And to kick it off, first thing is preventive maintenance, and I'm going to have Columbus take that.
All right. So going into preventative maintenance, we always want to start off with a visual inspection. Typically, because there are a lot of things that can be picked up, just by looking. Some of the things that we're going to be looking for when we're looking to repair some of these things is going to be rubs, splices, bare spots in your wire or your insulation, typically on the spots that are going to be having a little bit more tension on them. So if you're feeding into the bulkhead of a trailer, if you're making bends to make it into a channel, those are some key spots that you want to keep an eye on. But not only that, we're looking for properly terminated ends. So wherever that cable reaches its final destination, wherever it's going to be connected up to, we want to make sure that you've got proper crimps, you've got proper termination, and that your eyelets or the equipment that you're using is meeting the standards to be able to function properly. As we carry on this page here, you can see some previous repairs that have been done. Obviously, right out the gate, you can kind of tell what's going on and what we would want to be looking to repair. So on the left picture here, we're looking no heat shrink. Definitely want to make sure that our terminals and anything that has any kind of connection points is well protected. So utilizing that heat shrink is really going to help us out in these cases. And then noticing there in the center picture, we've already got some heat shrink going in there, but it tells me that there was obviously some damage to that cable at some point. So before we start diving in too far, we want to make sure that we're addressing the problems that are already existing. And then there towards the right-hand side of the screen, we've got some damaged heat shrink on there, which is, again, if this was exposed to the elements, is going to open up the possibility of corrosion, allowing moisture to get inside there and to really start affecting those connections.
And before we go, one I want to point out, the center one. So this is actually part of one of our systems and something we see regular basis. This is a 4-conductor harness that has to be cut to length, then that outer jacket stripped off. You can see that there's nicks in the wire where they cut that outer jacket off, and they put heat shrink on one of them, but there's still 2 that were nicked and not protected.
Right.
That if you look at the lifespan of a lift gate, what's going to happen to that thing in 5 years, 10 years, as long as that thing's going to be out there.
Absolutely. Taking every little precaution that you can is going to, put you further and further in a better spot. So moving on to checking your battery power and ground connections. So this is something that is all too common. If you get a road call, you've got a no-name repair shop that is trying to, make a change, midway through a trip. You always want to make sure that you're checking your equipment when it gets back to your facility or its final destination, just to inspect the batteries, look for loose connections and nuts. Because again, we can have proper connections all day long, but when we're talking about anything loose, that opens up the possibility of resistance buildup, and with resistance comes heat, and could eventually, do a wear and tear on your termination points. And then we're also going to be looking for any kind of corrosive material that is, or any kind of corrosion that's building up on either your battery or your terminals, or any kind of nicked and damaged wires. Typically, you'll see a lot of this up in the northern areas, but believe it or not, we get some down here in the south as well. The corrosion can be an absolute killer when it comes down to maintaining healthy wire. And for longevity purposes, you want to address this sooner rather than later, because I can't tell you how many times that I've opened up a battery box or gone and inspected some trailers and wiggled the wire and then have it almost snap in half in my hands. So again, keep an eye out, and green is not good in this situation. And then again, still focusing, more on the battery side of things, because again, this is where our current and everything is going to be flowing to and from. And we want to make sure that, again, everything is tightened properly. And just to make things a little bit easier on your batteries, not necessarily the cable, but it all comes full circle, is hook your battery power positive on one side of your battery set, and hook your ground on the other. That way that they're draining evenly, and then they're charging evenly in return. And this is another big one, battery hold downs. So though it doesn't have anything to do with your cabling, these batteries, if they're bouncing all over the place, things are inevitably going to start loosening up. You're not going to get as good of a connection. And then if it starts to damage the performance of that battery or the contents therein, then we've got bigger issues. So making sure that your battery hold downs are nice and tight and they're not just kind of bouncing all over the place is really going to help us out in being able to prevent any kind of wear and tear on our cables going forward as well.
Yeah. One other thing you notice in this picture, it's a battery box that's got two batteries. Those are two different makes and models of batteries, two different ages. You got to be aware of those things. Batteries should always be done in a match set. If you have one bad battery, doesn't mean the other one's bad. You got to match it up with a like for like. But you can tell here that, yeah, those are two different manufacturers. I guarantee they're two different specs on those batteries, and they're definitely two different ages. One thing I always highly recommend too for people, whenever you install batteries, grab you a paint pen and write the install date on the side of them. That way, that's when your warranty should start, is when you installed them. Not when they were manufactured, not when they were delivered, not when they were delivered, to your location as well, but it should start when it was installed. So that does two things. You can very easily look at that battery and say, hey, these things are 2 years old, 3 years old.
Right. At
some points, hey, you got your money out of them. Are you going to leave batteries that are getting past a certain age in, whether it's a truck, a trailer, reefer, that says, hey, we got our money out, we want to get them out, now before they cause us a road problem. The other thing too is look at and say, wait a minute, we just put batteries in this thing last week.
Exactly.
Is there something wrong with the charging system? Again, whether it's a truck or trailer, you need to check, because just popping another set of batteries is not going to fix it.
Exactly. And preventing, doing your extra steps ahead of time is going to protect you on the back end, or at least give you a better idea of where you need to be focusing attention should some of these batteries or cables and stuff fail prematurely. But with that, leads us over into our first poll question, and we'll give you guys a few seconds to go ahead and submit your answers on this. But how often are you doing PMs on your wiring? Now, this is not specifically pointed in any specific location, just as a whole, whether it's on your trailers, your tractors, your reefers, anything that you're using internally or on your fleet. How often are you checking up on these things, and making sure that you're doing your due diligence?
And just put your cursor over, A, B, C, or D, and then click on it, and it'll submit it for you. Give you all just a few more seconds here. Make sure everybody's got a chance, and we'll review it here in a second. Yeah, still got some people answering, so We'll pause for just a few. And don't be scared. I can't see who did what. So, you ain't going to be embarrassed or called out for it. Yes, people still answering. Yeah, we got a good group today. We got 60% have answered so far, 63. All right, we'll go ahead and go to the answer here.
Man, that's an awesome percentage right there. But yeah, it's highly recommended that every time that you pull a truck in for a PM, that you're always going over these things. Because again, everything going forward in the future is looking to be somehow tied into electric. So in hindsight, that just means more cables that you need to check. So making sure that everything is in tip-top shape is really going to protect you on the back end.
All right.
And with that, I think Larry is going to pick us up where we left off and talk about repairing some of these issues that we find along the way.
All righty. Yeah, that, one thing I do want to chime in on that, last poll question too was, it doesn't have to be a set time for a good inspection. One of the biggest things I always tell fleets is, if you've had a trailer or truck that's been, in a, road service type situation, when it does get back to the shop, someone needs to go out there and look at it. Or if you've had, some sort of retrofit stuff done, we've got that with some different fleets where they have an outside vendor doing, installs on gates or whatever. When it comes back, you need to inspect it. Did they do it right? You don't want to wait till, it does break down, or, wait all the way till it comes back for its yearly or whatever. So
Right.
you want to take a look at it and say, hey, I know they worked on this wiring here. We had a taillight problem or we had a liftgate problem, whatever it is, go out there and take a look at it. Make sure it was repaired right. Did they use cheap connectors? It's scary the things you'll see people use out there. So take a look at it.
Absolutely. Trust and verify.
The other thing I do want to kind of hit on today, this is not just, a Purkeys thing. We got a lot of information from a lot of people over the years, and two of the documents that, support a lot of this information goes back to TMC. And if you're not familiar with TMC, you need to. But there's two different documents that, there's a lot of this information covered in. And at the end of this presentation, there's a whole list we'll show you later. But two of the big ones we're going to talk about right now is RP 105D, which is an engineering document. When we say it's an engineering, it's more of, when building something new, this is how it should be done.
Right.
Then the RP 186 is more of a maintenance recommended practice. How do you go fix this? So it's not just, Larry's opinion or Columbus's opinion. It's just kind of industry standards and things we've done, throughout the time to do all this. But again, yeah, we're going to repair some of these things. Before you begin, you got to make sure you have the right tools. That, you got to have a good voltmeter to do any of your diagnostics. You got to make sure you got the right, service parts in stock, connectors, terminals, heat shrink, solder, a torch. And before you try to do any of these things, make sure you disconnect power. You don't want to be doing any of these things live, and then, you start off with one bad wire or something. Now you got a whole harness you smoked because you did something silly.
Right.
But, some of it you got to break down, what am I working on? Am I working on a cable? Am I working on a primary wire? Is it a corrosion problem? Is it a bad splice? Is a fresh install? And again, that's kind of like we were talking about before, the outside vendor or whatever. Same rules apply when you get a bunch of new trucks or trailers and you've had, different accessories added to them. Went to a PDI center, went to a dealership. Verify their work. A truck, I don't know if a fleet that doesn't hold on to a truck for at least 4 years. So if you start off with it bad, it's not like wine. It's not going to get better with time. So you want to inspect it. And then again, kind of breaking this up between primary wire and battery cables, which we'll cover later, because yes, they're the same, but they're very much different. So some of it's just, if you are working with wire, you're going to have to replace wire. Make sure you understand all the different, things with wire. Wire is not wire. That there's all kinds of different, spec codes for it. What is the insulation rated at for voltage? The wire type, whether it's a thin wire. becomes a lot more important when you talk, cable. That's, there's kind of general purpose cable, then there's what everyone refers to as welding wire. It's, what gives it the flexibility, how many strands. And for the most part, there's no difference in capacity by those strands. It just becomes the flexibility. But the wall thickness, and we're not really going to go into connectors today. We'll have to do a separate one for that, because that would take us 8 hours just to cover all the different connectors that are in the industry. But some connectors require a certain wall thickness. Otherwise, the insulators or the seals don't work right. But temperature rating is one of your biggest things. We'll go into that on the next slide on some of these different types. But wire size, again, wire's not wire. If you're replacing a 10 gauge wire, you can't replace it with a 16. Right. It's got to be the right stuff. And, most things anymore are color coded. I know way back when I first started doing this, most of the truck OEMs use one color wire for the entire truck. And it had numbers printed on it. And if you had sweaty hands, you wiped it off. So, but if you are replacing red wire, make sure you replace it with red. But this is, again, some of the more common specs and types of wire. The biggest thing that we always recommend is, a cross-link wire. One of the biggest things with that, and we can't show videos on here very well, has a tendency to slow everything down, but it's pretty interesting when you see what happens if you take a GPT or a general purpose wire and you overload it. It actually just goes up in smoke. Yeah. The insulation is such a low temperature, plus it reflows when it gets hot, and that's where you have one wire that melts. All the insulation is gone, and you take out 6 other circuits. Yeah, that when you see a whole harness that is burnt, it's usually one wire melted, and it caused all the other ones to fail. So the cross-link is what we use for everything. Again, it does not reflow, plus it does not combust. So it may get crusty if you get it hot enough, but it doesn't actually add to a thermal event. And that's some of the biggest reasons that we're talking about all this today is more and more fleets are having problems with thermal events, or is it a rapid, unplanned disassembly of a vehicle?
Yeah, I think that's the engineering term for it.
Yeah. But again, you got to look at all these things and make sure your parts room's stocking the correct stuff. If you've got just GPT wire in your parts room, years ago, we went through and we cleaned out everything of ours to make sure we had all the right wire for everything we were doing. I'm going to turn this back over to Columbus for, terminal replacement and repair.
That time again. All right. So terminal replacement and repair. So this is a common thing that we've all seen across the board. Sometimes you have the right stuff, sometimes you don't. You just work with what you got, and I'm trying to make sure that everybody's on the same page. So when you're dealing with bad cable crimps, it usually kind of revolves back around to the tools and the equipment and the materials and stuff that you have. So knowing what size wire that you're working with or cable, whether it's 10 gauge, 4 gauge, 6 gauge, 1/0, what have you, that's one of the big things that you can't just show up to a gunfight without having the necessary bullets in your arsenal to be able to perform. So this is no different. So making sure that you've got your right terminals, or battery cable lugs, or heat shrink, anything to protect you on the back end as we're diving off into this. It's easier to fix a job once than have to come back and fix it 3 or 4 times. So we'll lead just right off into this, choosing the right terminals. So when we're talking choosing the right terminals, you have to make sure that it is the correct size for your cable and wire, like I was just saying before. And you also need to know that, sometimes insulated terminals are not going to be the easiest or the more reliable to get a solid, successful crimp on, just because, every one is going to be a little bit different. And are you going to be using the right terminal for the job? You can't go in and replace a Deutsch connector with a ring terminal, or a spade connector with a Deutsch connector. And that's just one of the things that, take off and replace with the same thing that needs to be going back on. because there are so many different types out there that it's easy to get them confused, um, which is kind of leads us into the different types of terminals. So non-insulated is typically going to be your more uh, reliable. Yes, it's going to require a little bit extra work, but you get to control what happens a little bit more on there, as far as being able to double verify that you made a solid crimp, go through and solder your connections a lot more easier, um, and then be able to go back and put some reliable heat shrink on there to protect that circuit that you just fixed. Now, the vinyl coated and the nylon coated um, terminals, yes, they do function, but again, it's going to be a lot harder to get a solid connection on there and more or less go through and be able to heat those up to a degree where, one, they're not melting, and two, they get a solid seal on that wire that you just crimped on. And then you have the solder sleeves. So solder sleeves are really, really cool, I think. But at the same time, you're opening up a can of worms and leaving the door open for a cold solder joint, something that's just maybe not going to get the best hold. You'll get a good seal on the heat shrink side of things, but as far as mating those two connections together, um, it could be a little bit more desirable to use some of these non-insulated and be able to solder it yourself.
Yeah, one of the things is, there's a reason why we put the international symbol for no on the vinyl coated. Those have no place on a vehicle at all. Again, you got the exception. Hey, he's on the side of the road. I got to get this, hooked up. But unless it's 5 minutes or less, these are not ever going to be a good connection for you. The nylon heat shrink, they are better. They do have a heat shrink quality. But the bad thing about them, most people don't have the right tools to do them, and they wind up, puncturing, putting a hole in them.
That's true.
They don't get the right, crimp on them. They use a different type of crimping process or form than some of the other ones we're going to talk about. But one of the biggest things that I see, nobody ever heat shrinks them. So
yeah.
You're spending a lot of money for a terminal that's, you're not even getting a good advantage of anyway. And the solder sleeve, like Columbus was saying, is those are very expensive for what you're getting. You can buy a bare terminal and lots of heat shrink, a lot less money than the solder sleeves.
Absolutely.
And the biggest things that I do see with them is, it's such a low temperature, solder they use. You still run the risk of having a cold solder joint because you never get the wire hot enough, because there's that fine line between melting or burning the insulation on them before you get everything hot enough to get a good connection.
Absolutely. So we talked about all of that to talk about this. So when to repair and replace. So when we're trying to make the decision on this, we have to first ask ourselves, can it even be repaired? So we're looking for broken and twisted eyelets or terminals or butt connectors or anything like that that would kind of give us a little bit of an understanding of, yes, we can go through and replace this, or we're not going to have enough length because there's so many butt connectors in this sequence that we're just going to have to replace the whole thing. Or is it just a bad crimp? If it's a bad crimp, you typically can just go ahead and nip off that terminal and then strip your cable or your wire back and then go through and reapply. Or if you're just replacing cable, or you're doing a fresh install, it's good to go ahead and use these practices going forward and knowing what you're doing to better protect yourself in the end and prevent you from having to come back and rework something that you just spent all that time doing in the first place. And with that, it is going to push us over into our next poll question.
Let's see if everybody paid attention.
Absolutely.
We mentioned 2 RPs a little bit ago.
Yep. So which one of these RPs is going to be the one that covers your battery cables, your terminals, your heat shielding, grounding techniques, wire gauge, and replacement wire selection? Again, we'll give you some time to go through and select your answer, but it's definitely one of those things that you want to know, and it's very easy to access some of these things and to be able to push to your technicians or your shops, just to kind of give a little bit of more of an educational value and to make sure that you're practicing what you preach in a sense, and making sure that we're following everything by a certain standard.
So yeah, worst case, take a guess here, but yeah, we mentioned two specifically. So yeah, one of these, covers a lot of it. Again, it's the engineering RP that we'd mentioned before. So far, we got about 20% answered. We did have a couple questions that came in before that we'll answer once we get past this poll question. Let's see, 38% have answered. Give it just a few more seconds, see if anyone else wants to. All right, we'll go ahead and go to the answer here.
All right, looks like everybody's gotten their vote submitted on here, and seems to have everything kind of on par across the board.
Pretty even, but yeah, the correct answer is RP105D. That is the engineering one. Someone in the chat put in 186. That is the one for repair, which we did mention earlier, but yeah, it's not for design. That one's for repair. And we'll go into that a little bit more on the repair side.
Absolutely.
A couple other questions did come in was, is nylon heat shrink okay to use? I'm assuming you're talking about the nylon heat shrink type terminals. If they're properly crimped, which we'll show you that here in a second, they're not my favorite, but they're still better than a lot of the other options.
That's true. But again, it defeats the purpose of using those nylon terminals when you're not heat shrinking. And that is a big thing. If you're gonna do a job, do it fully. Don't do it halfly. And there's another saying for that, but I won't use it.
Someone asked about solder paste, and I'm not sure in what application you're talking about solder paste. If you're talking about using a resin or something to prep it, as in like a cleaning agent paste. If that's the case, then yes, it does help make sure you get a good solder connection on it. And one last question that came in was, what if we have no slack after we cut off connection?
And this is a great question, because it's one that every single one of us that's attending and viewing this has ran into at some point in their journey, right? So we are trying to make that connection work. And yes, we'll touch on this a little bit later going into there, but you can make that judgment call. Is one, am I confident in my crimps? Do I have butt connectors? And depends on how long that section of wire is that you're needing to add, because you have to keep in mind that anytime that you make a break point and then reattach another wire, is you're creating a resistance buildup regardless. If you did a perfect crimp or not, there's always going to be a little bit of resistance, a little bit of voltage drop that comes along with that. So to minimize that, you want to try to keep that length just as close as possible to its final destination, so that it's not as much of a detrimental loss than it would be if you did that halfway through a harness.
Yeah, and it is a tough question to answer, because depends what it is.
Right.
If it was, for example, our harness for liftgate charging, and someone ran a fork through underneath the trailer or whatever and cut the whole thing in half, I'm saying, no, replace that whole harness, because now you've added extra ground connect or extra resistance and power in ground, everything else. So I would be very scared of that.
Right.
The other thing you got to be careful is if you're working with something like twisted pair, are you going to impact the twisting of that's going to cause you other problems? So yeah, it really depends. What it is. Yeah, sometimes I'm going to add 6 inches of wire just so I can still reach it.
Right.
As long as it's done right, you put in the right type of wire, proper crimps, everything, probably no harm, no foul. But I'm not ever going to say across the board, yes, increase the uh, uh, length of something versus replacing it. Someone else, what's the difference between heat shrink versus crimp terminals with heat shrink? One of my biggest things, when we talk about that is if you use a bare terminal, you can see it. You can use to me, what's a much better type of crimper, which we're going to show you that here in a second. So you're going to get a better crimp than the other ones. Plus, gives you the ability to solder it. You can actually take a small torch or a soldering iron, solder it. Then you're going to put your heat shrink over it. It's going to give you a much better seal than the other one. Again, the problem with the ones that have the heat shrink made into them, you can't solder them, and most of the time we see them that someone did it, they didn't use the right crimpers. They cut through the insulation. You can't see how well the crimp is, and you generally wind up with an inferior crimp and not a sealed connection when it's done. So one thing, keep in mind, all these pictures we're showing you, and probably several hundred more we both have on our computers from trips, is there's a lot of oopsies that happen out there that nobody ever fixes.
Absolutely. And the biggest thing is when you're dealing with some of these terminals that have the heat shrink, whether it's the nylon or the plastic, once you ruin that integrity of that heat shrink by going through and following up with your crimp, if it's cracked, broken, or what have you, as soon as you go to heat that up, if you've experienced it in the past, you'll experience it again, is it has a tendency to roll a little, which again, it doesn't ever, give you that really reliable seal on that terminal, which again brings us back to the corrosion point, is you're opening up the door for more moisture, even if it's, something that may not be exposed to the elements all the time, that is still something to consider when you're going to pick out, what terminals you want to equip on, your shop floor or in your mobile repair. Best to have what you need to make sure that you're performing quality work.
All right, we're going to go a little bit of the tools. And again, this was just a snippet straight from RP 186 of, the right tools, what's recommended, what's not recommended. And this is a very small look at tools. We're basically dealing with, basic, eyelets, butt connectors, things like that. And the ones on the left versus the ones on the right. That the ones on the right, the problem with all those, they're all going to puncture. They're not going to get a good crimp on it. And at least these are all still labeled crimpers.
Right.
The number ones to see in the field where someone tried to do these things with a pair of pliers, those are not crimpers. Those are pliers. And these all have their own place. Depends on type of terminals. You can't, well, it's a terminal, crimper, so I'm going to use it on this. It's like, no, you're not. And again, talking about the types of crimps. Go back to the previous slide, I'm going to flip-flop here a little bit. This is what's called a double D crimp, where either this would have, ears pointed up that are going to, bend into it, or when you look at the barrel of a terminal, the whole idea is to force it down in, and it gives you a much better crimp, which is what, we'll go back here, the Packard style, or Delphi, whatever you want to call them, but they do what's called a double D crimp, because again, they fold it over back down into itself. Gives it a much better, you don't have any voids, you've squashed it all in there.
Right.
And that will take solder very well. It'll wick right in, fill those last little parts even. Then again, soldering it or heat shrinking it, and you've got a bulletproof connection that's going to last a long time.
Right. And not only that is, let's say, for instance, you were to make a bad crimp and you have a lot of empty space, that, yes, the wire is holding, but I mean, if you're looking through it, you can see daylight, or you can see some gaps that are not filled. Again, that opens up an area that could experience a high buildup of resistance, which with resistance comes heat, and with heat comes thermal events. So it's one of those things that, uh, like I was saying before, trust your crimp, but also verify and make sure that uh, what you're doing in the field or what you're doing in the shop is going to be something that is going to be of quality work and a solid crimp, so that way you're not having to come back and redo what you just spent time doing in the first place.
And keep in mind too, we're not here to sell you tools or terminals.
No.
And we'll talk a little bit about some of the different ones. We'll go through them here a little bit. But first, we're talking about just doing a splice, or a butt connector. Um, Probably the most often repair that's made. Either something got nicked, it got cut, braided on something, chemical damage, whatever. But we're talking splice wires, and these can be repaired many different ways. Some of them just simply stripping them back, twist them together, solder it, and heat shrink. Again, this is talking about the insulated terminals we told you before. These are the nylon ones. You have to make sure you strip them back the right length. Again, doesn't do you any good to do the heat shrink on them if you still have a 1/4 inch of wire sticking out beyond it. And you're probably chuckling to yourself, but we see it all the time.
No, absolutely.
Then they wonder why when it touched something, it blew fuses or they let the smoke out of it. But they are color coded. The other thing you got to be careful of too is, depending upon different brands, you can still have differences here, which gets even more important when Columbus talks about battery cables later on. Is a certain brand has a certain thickness, and if you mix and match, you may not crimp it hard enough. You may crimp it too much. I saw one of these, on an eyelet one time. Someone crimped it so hard, again, didn't use the right ones, but they basically cut it in half. The only thing that was holding it together was the heat shrink. Yeah. And for extra measure, they put a big old blob of red stuff over it too. And if you hit a bump just right, the system worked. If you hit a bump the other direction, for some reason it quit.
And that just makes the whole process a lot harder to troubleshoot.
And here we're showing, again, the same thing, show that first slide is, the wire simply, strip back, twist it together, good solder, and make sure you use electrical solder, not plumbing solder. Plumbing solder has an acid in it. And, you spend all this time making a good connection, you just sealed an acid that's going to corrode and degrade that connection inside of it. Again, too, good heat shrink. Always recommend a dual wall where it's has the actual plastic to insulate it, but also has the adhesive inside that's going to totally seal it. You got to make sure you have the right stuff. Heat shrink only has a certain range that it works. That if you put 1/2 inch heat shrink on a 16 gauge wire, there's no way it's ever going to shrink down properly and seal.
Right.
This one's using a bare butt connector. Same thing, strip it off the right amount, put it in your crimp. It's hard to see in this picture here, but you can see that line where those crimpers actually, again, folded it into itself and gives you a bulletproof connection. But one thing is, no matter what, I would always still rather a solid whole original wire than any repair you're going to do. It's always still going to be best, but you want to make that repair as good as you possibly can.
Absolutely.
All right, now I'm turning back over to Columbus. He's talk about, when we talk about big battery cables.
Oh, all right. So again, this is nothing that's not familiar to everybody, but when we're starting to talk about battery cables, there's a lot that goes into play with that as well, especially the tools. Now, though you may be familiar with the old where's my hammer and let me smash this thing, it is good to go ahead and practice, and get yourself a good pair of lug crimpers. Now, the majority of these lug crimpers are stuff that you'll find either online or on a parts truck or at a hardware store. They're going to have interchangeable dies or rotational dies. And what that's going to allow you to do is to either size up the bite, or it's going to have you be able to go through and size it down depending on the cable size that you're going to be using. And then over here on the right side is one of the newer inventions, that's starting to, really make a rise in different shops, is the electric drill style crimpers. And essentially this is just going to put a solid, kind of like a vise kind of clamp on there to be able to make that connection as solid as possible when you're putting on your battery lugs.
And one of the things is again, talking tools, Columbus and I have both been in, probably hundreds of shops. And one of the things most people do not have is a good set of cable crimpers. They're not that expensive. There's two different, well, we say there's four different styles, but there's a small unit that usually is good up to maybe 1/0 cable.
Sure.
Then, those are maybe 1.5 2 foot long. Then there's other ones that are, 3.5 foot long, look like great big bolt cutters. Those will go up to usually, as high as 4/0. You don't have to spend a ton of money. You can buy, inexpensive ones, mail order tool trucks, whatever. But you got to have them. They're designed to do a proper crimp. The staker thing in the middle, again, if I was on the side of the road and that's all I had, yeah. But that's still probably better than I was at a place one time and they were doing battery cables for a liftgate and they were just hitting them with a hammer on the ground.
We were in the parking lot and they were doing them with a hammer there.
And so you're never going to get a good complete crimp on it. You want to, again, push in from all the directions and make that a solid chunk. If you do a proper cut, it's kind of like that terminal we showed you before with the double D crimp. If you ran that thing to a bandsaw, again, you will not have any voids in there. Every bit of surface is going to be filled with wire. So you got to make sure you use the right one. The one on the right, the battery powered, pretty damn cool. I've used them a few times. For big battery cables, they work pretty well. They're a little slow cycling, but they do a good crimp. Again, like anything else, there's 20 different, makes and models out there.
Sure.
But they're expensive. It doesn't do well when someone, drops them and everything else. But that is kind of the Cadillac of the options, but you have to have a good set of crimpers. And also you got to have a good set of, cable cutters that'll cut cable that big.
Yeah, absolutely.
If, I've had people use a Sawzall or, a pair of dikes and sit there and whittle across it. You'll have a very hard time ever getting them to go in the right size lugs, which we're going to cover in a couple slides.
All right. So kind of moving on and then moving back at the same time. So going into different cable selections or wire selections, it's still going to be right along the same concept. Still going to be looking for that cross length is always going to be preferred. But then you can also think about that thermoset elastomer type cable or the STR. And that's, again, going to be something that's going to allow it to heat up to, higher temperatures and still keep its elasticity or to be flexible in a sense, just like the cross-linked will as well. But again, make sure that, you know what kind of cable is going into your equipment, especially if you're doing a repair. Because like Larry said, you don't want to be replacing anything with something that is going to potentially, become a hazard down the road. And now proper lug selection. This is one that I have seen far too many times. And I mean, Larry's a little bit older than I am, so I know he's seen it a little bit more. But making sure that you're using the right lugs, making sure that you're using ones that the eyelet size is the proper size, that you're not having to take a drill with a 3/8 bit and boring it out. Because again, anytime that you do that, you are ruining that integrity of that lug. Will it work for a pinch? Absolutely. But again, you want to make sure that you know what you're using. And if at all possible, go with the tin-plated copper lugs versus going for these brass or just straight copper lugs themselves, just to kind of give you a little bit of extra protection on the back end from some of that corrosion that you might find, as the road spray or chemicals is splashing from up underneath the truck or up underneath the trailer. Again, it's going to improve the longevity or the lifespan of these terminals and prevent you from having to go through and replace them, 2 or 3 years down the road. Again, tips for good crimps. Like I was saying before, if you're using a rotational die or an interchangeable die crimper, make sure that you know which die is for what. They have them from, all the way up to 4/0, and possibly even higher. I don't know what that it would look like as far as cable size goes, but I know that my body weight, doesn't have enough to really get those crimpers breaking it over at that point. And then make sure that your lug and your terminal, or your terminal, is right for your cable size. There's been a lot of times that I've seen different locations, they'll go through and they may just have the wrong size, and they're smashing that lug down over the copper and then causing it to fray out, and then having to go back through and trim off that excess copper wire that is just not able to fit in there. And I can promise you that is not a good practice to do, because at that point you're ruining the integrity of the cable and what it was designed to be able to withstand and be able to allow it to kind of pass through. And if at all possible, especially with your battery lugs, do a pre-solder. If you can heat that terminal up to a point where you can melt solder and fill that, and then shove your cable in, that's just going to, only strengthen that connection that you're going to be able to have going forward, and down the road, and making sure that, everything is going to get the best connection as possible. And then come back with, like what Larry was saying, is get you a good tube, a foot and a half, 2 foot at all times. Just cut off what you need to be able to further protect that cable and that lug. Because again, if you throw this off into a battery box anymore, these days you've got 10 or 12 things that are going to be pulling power off of those batteries. So as everything is stacking on top of each other, it's good to make sure that nothing is going to wear through and again ruin the integrity of the cable or the lug itself.
And one thing I do want to make sure to specify is Columbus is talking about, putting the solder in the lug or whatever. Is I used to watch it on one of the car shows that people would do that. They'd fill a lug up with solder and shove the cable in. That you can wind up a cold solder joint if that's all you do. That you want to make sure that you apply heat and more solder so it sucks it in and fills in all those voids. If you just shoved it into a pot of melted solder, you're going to wind up with a very cold solder joint. So make sure you crimp it, solder it, while you're applying the heat so it sucks that heat in, or that solder in. And if you have the good crimpers, you get into the big battery cables, I'm not sure you'd even need to solder. Again, if you're using the right crimps. Because again, you run those things through a bandsaw or whatever, you've got a solid chunk of copper there. It's the ones where you're using the staking tools or a screwdriver or all those crazy things you see people do, then you better solder them. The only one issue with that is you got to be careful of it'll actually wick up the cable the other direction, and you wind up the last 4 inches of the cable that has no flexibility because solder's all wicked into it as well.
Yeah. All right. So now we've covered a good portion of how to replace and pick and choose our terminals. So when do we replace this cable? And a lot of times is why we were recommending those tin-plated copper lugs is to prevent corrosion. So let's say, for instance, you've got a nick in that wire, you've stripped the sheathing back on that cable too far, and you've got exposed copper now protruding from that lug that you just crimped on. Where do you think that's going to be, 2 or 3 years down the road? Chances are it's going to, have some corrosion buildup because it's just not as protected as it possibly could be, which then turns around, and now we don't know how far that corrosion has set in until we start, again, stripping it back further and further, and before you know it, we're down to 6 inches of cable that we can work with. So if you experience a lot of that severe corrosion, or as time goes on year over year, your cable is just baking, heating, and becomes brittle, and just from the elements itself, it's a good practice to go ahead and replace that cable, just so that you're making sure that it was when it goes back into service, that it was designed to, or it handles to the job that it was designed for. Sorry, I was sitting there tripping over my own words.
And one thing I do want to chime in here, I just thought about it. When we're talking here, we're talking about copper cable. One truck OEM a couple years ago made a decision to make all their battery cables out of aluminum. If you do have those, do not try to repair them. There's no way you're going to do a field repair. So if you've got any of those, you're going to have to pull that entire cable out and replace it all. Most of them, I believe, were recalled, but if you do run across that, you cannot do a crimp on copper wire. So, or copper cable, well, either thing. If the wire's made out of aluminum, replace it 100% no matter what.
All right, and then corroded cable. This is kind of, again, what we were just talking about, and some of the causes and effects that it'll have on the cable itself. So all of the road spray and chemicals and stuff that are splashing out from or splashing up underneath your truck, underneath your trailers, it all gets absorbed in some way, shape, or fashion, and finds its way into our cabling or our wiring, regardless if it's a main current bearing cable or not. We've seen it rust out the undersides of trucks and trailers as it is. So what do you think it's going to do to your cable? Because once it sets in, now we've got some things that are going to, start causing even more issues down the road. And, a big part of that is going to be resistance. Or in this case, as we're, referring to it in the slide there, is voltage drop and overheating. So again, it's not going to be able to provide that solid connection that it once had. So when you're taking voltage readings from your batteries and then wondering why it's not the same, at point B, this is potentially, because of that. And it's also even been known to cause, short circuits in certain applications, depending on what that cable that is affected is being used for. So again, if you see green on any of your cable, you need to dive into that right away and make sure that you're addressing it versus just, saving it for a rainy day when the truck or trailer rolls into the shop.
Yeah, and the other thing on all these is no OEM gives us any extra cable. Especially you talk about 2-aught, those are obviously very expensive cables.
Sure.
So if you start seeing corrosion, you better fix it now, because if not, and that stuff wicks up in that cable, some of the OEMs don't do a real good job of, heat shrinking the factory cables. If it starts wicking in there, you're not going to have a choice. You're going to have to replace the cable. And to do it right on some trucks, that can be a several-hour project. So fix it as soon as you see it and get it addressed. And we're going to run out of time, so we're going to have to talk a little bit faster to cover these last slides. But I've got one more poll question for you. Why is selecting the proper wire insulation important? Again, A, B, A is chemical protection, B is abrasion protection, C is temperature rating, or D, all the above. Let everybody answer right quick. Uh-oh, I think everyone's okay. People are starting to answer now. I started to wonder if everybody went to sleep on us.
Man, either that or we were talking too long and we took lunch.
All right, we got 44% answered. We're at 49% answered. Ooh, jumped up to 58. Again, we'll go ahead and move on. But yes, all the above. All of them are very important, and they all have different, reasons and specs to them. There's a reason why SAE made all these different, ratings and types. That's where some of those, engineering and other documents come into play. Is you got to know what you're using it for, where it was. Am I going to get a lot of chemicals on it? Am I going to get a lot of heat on it? What's going to be for abrasion? All those things are important. So there's not a one size fits all. That some of them may be better at abrasion, but they're very easily attacked by chemicals. So you got to make sure what you are using. Just some other good rules to go through here right quick. Is know your path. Whenever especially when you get into big battery cables, those things usually have dedicated P clamps or whatever underneath. They're mounted to the bell housing, mounted to the frame, battery box, whatever. make sure you put it back in the same place. I can assure you, if it wasn't necessary, the OEMs would not have spent the money for all the clamps and wire ties that they do. And I know someone that's on our webinar today that is a huge person for that is, the whole, clipping and tying, make sure things are secured properly. You start getting a big battery cable that chafes and grounds out. There's no fuse on your starting circuit. So if it grounds out, odds are you're getting a new truck before it's all said and done. Go the extra step, high current, and right now we're still talking just a straight 12-volt system. One of the new trucks, and now you're going to start seeing a lot more, some of it's going 24-volt for cranking and charging. Then you start getting an EV where you got hundreds of volts. So you got to make sure you're doing all of the right things. Is it protected with conduit? If it's somewhere you say, hey, we're seeing a lot of issues with that may be something you're going to have to get some heater hose or something to slide over to make sure you're protected.
Absolutely.
Then, some of the last things we're going to talk about here is testing it. There's two things you got to do when, it's part of testing. That's, again, physical examination. Is you just went through and you did a new crimp, you did solder, you did heat shrink. Did it all get done properly? Did you do the right crimp? Is it too far out? One thing you got to be very careful with battery cables, if you don't crimp them in the right, do it in the right order, that if you crimp closest to the eyelet, you can actually squeeze your cable out. And you think you've got a 3/4 of an inch of wire up in this terminal. Turns out you only got a 1/4 inch, and you go to tug it, it comes right out. Mm-hmm. So you got to be very careful on that. But the other thing we see at times too on some of the smaller wires, people put the heat shrink on, and they put it too far over the eyelet. So when they go connect it to the terminal block, some of the things we showed you in our systems, half the connections insulated because the heat shrink's out too far.
Right.
Again, pull test sealed, that's an inspection still. Is if you didn't use the right crimpers, did you puncture that insulation? But the last thing, again, no matter what, is you have to test it. And one thing everybody forgets is, when you're testing a circuit, you have to put a load on it. If there's no voltage drop, you can't have, or if there's no current, you can't have voltage drop. So you have to apply a load. You got a little, drawing here of it. It has to be tested under load, doing a voltage drop across it. But you have to know what that load is. There's a huge difference if you're testing a side marker light versus testing a blower motor versus testing cranking and charging cables. So you have to know what that load is, make sure you're doing a fair comparison.
Right.
But you're going to do a voltage drop across that and know, hey, did I do a good connection here? And some of those is, when we talk about cranking and charging, there's, again, a TMC spec RP129 for that. It spells it all out. There's a lot of things. There is not a written spec. So you may have to develop your own. It says, hey, we see issues on this, circuit all the time, that we know, hey, we're going to have to test this one at 5 amps or 10 amps or 27 amps, whatever it is. Let Columbus do the...
All right. So this is our final poll question here for the day. So to properly test a repair, the circuit should be what? A, tested with an ohm meter. B, tested under load. C, checked with a test light. Or D, load until the smoke comes out.
Let everyone answer that one. We got 6% so far. 21%. And somebody did just ask a question. There'll be a video after this. Yes. All of our webinars, if you register for them, the next day, usually right at noon, 24 hours later, you will receive an email that has a link to the recorded version. So you can go back and watch it at any time you want to. You can watch it 10 times if you're really, really bored. And if you're a service manager or shop manager or whatever, we can give you reports on this. So, hey, I can look up all the people from your company who all watched it. As long as they sign in with a unique email, One thing that we have a lot of happens is shops will have, 10 guys in a conference room watching or whatever. I can't tell you that, but
Right.
afterwards, if they watch it individually, yes, we can go back through and look at all that too. So we'll see our results here. Yes, tested under load. Somebody did like my joke though of load it until the smoke comes up. That is not a fair one to do. Getting a couple of questions of issues. If you are having any issues, hit F5. It should kind of reboot the entire system. Again, kind of wrap up here. Please do not leave yet. I'm going to share some. Whoops, and now mine's even locking up.
There we go.
There is, at the end of this, there's several different, we've got them listed as videos. They're actually just blogs, but different things on our website. Are you buying the right wire? How to make a good crimp? How to prevent wire intrusion? And then we have a ton of references going back to TMC. Again, a little delay here. But again, please don't leave me because I do have some survey questions and stuff for you I want at the end. Oh, I was loving we have technical problems at the last minute.
Gotta love it.
But it will be followed up. The last few slides we have are just lists of different RPs and stuff. I believe that's all in the references for this webinar too that you can go back and look at, along with Columbus's contact info, my contact info. If you have any questions on this and want to follow up, again, we do have some not poll questions, but some survey questions. We'd like for you to hang on. Make sure you answer those when I wrap up. But thank you for being here.
Absolutely.
Hopefully this was a help. If you got suggestions you want us to go into more or whatever, please let us know.
Yeah, reach out to us. Give us a little bit of constructive feedback. As long as it's positive, then I'll listen to it.
But other than that, we'll let you go. Thank you for staying for the whole hour. Whoops, now that it decides to work.
Yeah.
It finally moved one.
I was just waiting for you to be done and over with.
All righty. Well, thank you. And the survey should pop up here right directly.
Thanks, everybody.